Okay, so our first problem that we're going to try is 1D in this case. Does the spider catch the bug?
Yes.
So the spider can catch the bug. Let me show you as far as conceptual understanding what you're going to do. Basically, you're trying to say, does the x equal the x and the y equal the y from each different parametrics?
Y equals X.
What? Oh, my bad. My bad. Thank you. Y equals y from those and from these. But the key is when the time is the same. Okay? So you're trying to find the positions, do they equal the same thing whenever the times are the same? Because you can cross positions, but if they're at different times, no, you're not going to catch the bug. Okay? It has to be at the same exact time. Questions on that? Okay. So what we're going to do is we're going to quickly find when one is set equal to the other, what is that x position, and does it happen at the same exact time? You with me? For instance, let's do this one. Let's do the x. Now I'm going to show you with the calculator, so be handy with the calculator to follow me in that respect. Here we go. We're going to say, when is this x equal to this x? Whoops. We're going to try to find the time of when they're equal to each other. You with me? Okay, so in our calculator, we're going to do the solve feature. 6 minus 2t is equal to negative 4 plus 2t. And we're going to do the solve feature with a comma t. Okay? Alright, so let me show you with that. Some of you already have it typed in, but I might need your help. I'm going to put menu 3.1, 6 minus 2t is equal to negative 4 plus 2t, right? And then comma t. And that happens when at 2.5 what? Seconds, you could say, minutes, it doesn't matter. So we're going to come over here, we're going to say, so right now, that's a good question. Degree doesn't matter right now because we haven't entered anything that's sine, cosine, tangent, any trigonometric we have not done. So degree does not matter. It only matters whenever you're working with those things. So t is equal to that x, same value of x, whenever it's at 2.5. Now what I want you to do is I want you to do the same with the y. You'll do solve feature, okay, when 7 minus t is equal to negative 3 plus 3t, and then at the very end we'll do comma t, because that's what we're looking for. Okay? Tell me what you get, or actually I'll just do it. Menu 3.1, 7 minus t is equal to negative 3 plus 3t, comma t. And you see that you get the same exact what? The same exact time. So the x's are the same at 2.5 seconds. The y's are the same at 2.5 seconds. So will they be in the same location at 2.5? Yes. So the bug gets captured by the spider. Cool. All right. What's another one that you want to do from the homework? 2A. All right. So I'll tell you right now, this will be on the quiz. And the way that you're going to solve this is basically, some people skipped it because they weren't listening. There was only maybe 2 that skipped it. You're trying to put y in terms of what? X. Okay? So we don't want any t's in our functions. So step 1, you help me out. What do I do? Those of you who know what to do. Yep, we're going to solve for t from each of these. Okay? For instance, solving for t on this one, I'll add 1, and then I'll divide by 2. This is t. And I'm going to put it right here on my y equation, because we want it in y form, negative 4 plus 4 times what I got here for t. Go with me? From here, I would suggest to you, if you struggle with fractions, put that as 4 over 1. Because you're going to multiply, and you're going to multiply. You see what I'm doing? So I get what up top? 4x plus 4 over 2. And the rest of it is still here, that if you can't see it right now, you could break this up into two fractions that look like this. 4x over 2 plus 4 over 2. And then the rest of this will go right here. You with me? What does this equal? 2. So 2 and negative 4? Negative 2. So this one is going to be 4x over 2, which reduces to what? 2x minus 2. So there's the first one. And you're going to do the same. Again, we're going to do it for practice. We're going to solve for t. Now look, if you decide to take calculus, which I know a lot of you could do well in that class, you do, there's a lot of negative mistakes in calculus. So what I try to teach as early as I can is if I'm looking for a certain type of variable and there's a negative in front, try not to divide by the negative at the end. There's too much to work with, okay? So if I were to add the t over to the left and then subtract the x, I know it's subtle and simple, but with other more difficult ones, that's what your approach I think should be. You're going to plug this in for t. So that you have y is equal to negative 2 plus 3 times 3 minus x. And this is a lot easier. So that I would get negative 3x what? Plus 7. Done. Okay? Y is in terms of x. First step, solve for t on the x function. When you get that, plug in that value for t where y is equal to. Okay? Alright, one more question, make it a good one. Perfect, that's the one I wanted you to say. Okay. Okay, after I show you this, I'll show you that shortcut that I was talking about earlier with the calculator. Well, let's draw this diagram as best as we can. First of all, can someone tell me what these parametric functions are going to be? X is equal to what? Yep. Cosine of 25 times t. Not on the x though. So that is a common mistake, but you're not going to add 42 on the x. Because if you did, that means that person didn't start here. That person started 42 feet to the right. Okay? So we're assuming that this right here could be the x and y axis. So that the origin is right here. Go with me? So you're starting at a value of x of 0. And that you will always do. What I want to look at now is the y. What's the y equation? Yep. Perfect. Okay, so it is a minus, this is important, a minus 16t squared, and that's that gravity component. Because if you derive it, which you will learn in calculus, you get negative 32 feet per second. You have to memorize this, yes. So minus 16t squared. And normally, it would be plus 0, which nothing would be written there. But because of the fact I don't start at the ground, I'm going to put what? 42. Almost think of it like a vertical shift 42 units up is where you're starting. Okay? Alright. So now what we're going to do, we're going to put this into the calculator, and I am recording so that you can use this for later to prep for the test. Let me try to go through it as methodical as possible that I want you to go through the steps. Okay, here we go. First of all, let's go to the calculator. Now, calculus is going to be using your calculator. All kinds of people are going to be using your calculator. So let's home to menu C, OK, OK. So there's your calculator. You get one for a new document, one to add a calculator page. Yeah, I'm about to go through that. Okay. Then control add a page, Otherwise, Control Dock and press 2 to add a graphing calculator page. And immediately, right now, just like Eric said, I want to change the graph, which is the most important one if you're doing the trace feature. I want to change this to be what? Degree mode. Because look, watch me. If I go back to this page and I press Home 5.2 and I make this degree mode and I make it my default, and then I press 4 to go back to the current document that I created, look at this. This document right now is, it is in degree mode. That's in degree mode. But if I press Control and then that right arrow button, you can see that one is not in degree mode. It doesn't change both. And some people missed this on the quiz today because they forgot to change the graph. So the graph to change, you're going to press Menu, 9 for settings, and it's this second one right here. We want that to say degree mode, and then go and make it your default. Okay, now you're ready to rock and roll. Calculator page is in degree mode, your home page. Guys, I'm going to show you a lot of shortcuts today that you can use. It should make things a lot easier if you know how to use this calculator. Here we go. First of all, let's put up the parametric functions. With me, press Menu, 3 for graph entry, 4 for parametric, and now we're ready to put in these values that we got from the problem. What were they? 12 and 25? Okay, so 12 times the cosine of 25 times t. Now we're going to do 12 times the sine of 25, close parentheses, times t. Some people forgot this t. Some people forgot this t and it threw their graph off, even though they remembered after this to put minus 16t squared. But what am I missing right now on the y? Plus 42. What t-step did it tell you to use on your homework? Did it tell you anything?
Yes.
On this specific problem? It didn't. So what's our default that we talked about last class? 0.01. Alright, so we're going to go 0.01. And then, how long do you think this water balloon will be in the air? 5 seconds is a good amount. Now, when I press enter, you may not see the graph. Okay? There's a good chance that you will not see the graph. So the best way to find the graph is to do Menu, 4, Fit, which is A. Fit the graph on my page. And there it is. Well, there it is. Okay? Now look, it's a little bit messy. If you have OCD like me and you wanted to move this around, you could soft mouse on top of it and you see the hand open, and then just press it and hold until it closes, and then you can let go and soft mouse it off to the side if you wanted to, and then press the button to release it. Alright, now the reason why I showed you this, guys, is because I want you to determine what is a good window that you want to create on your calculator. And this is the window that I would suggest. Personally, I would look for this kind of window. Can you tell me what your x value is here? 0. What do you think this x value should be here? If this way over here is almost 60, what would you say for that? 20, maybe 30? Okay, let's do 30. Now, what is your y minimum here that you're going to put? 0. And what is your maximum y that you're going to try to put? 50. So now, when I go to the calculator, I'll press Menu 4, 1, so that I can customize this the way we got it, 0 to 30 and 0 to 50. And now the graph is sitting there pretty so that you can really analyze what it's doing in that first quadrant. Okay, any questions right now? Okay, can you do the the feature of finding the X-intercepts and the zeros and the maximins? You cannot. You can't do that from here. Okay, so if you wanted to trace it to see when it hit the ground, when when it hits the ground, what does that mean? What is 0? Y is 0. So guys, when you are trying to hit the ground, your parametric, you're trying to see when is this function, which is all of this, when does it equal 0? I'm about to show you something really easy to minimize the work that you do on this test, okay? There's two ways you can find when this is 0. The first one is what I taught you last time, how to trace. Let's do that, then I'll show you the faster way, and then I'll show you an even faster way, okay? Here we go. Press escape to get rid of that little window there. And now what we're going to do is we're going to try to find when y is equal to 0. Follow me. Menu 5, 3. What do we put in here? 0.01. And then we go menu 5, 1 to graph trace. And now if I do left and right, I'm going to scroll on this graph. And I'm going to scroll until my y value gets as close. So that's x. And this is y. And this is time. Okay? So I'm trying to get when y is as close to 0. So as close to 0, which one's closer, 0.33 or negative 0.188? Negative 1.88. So it's happening. This is the key word in this unit. It's happening at 1.79 seconds. How many decimals do I want? 3. So that's not going to show you 3 unless you shrink this step size even more and more, which is annoying. Okay? But at least you know how far did it travel x-wise to the right after 1.79 seconds? 19.5. And if you look at your diagram, as far as your homework is concerned, see if I can soft mouse this. It won't let me. The diagram shows the car. The first car is how many feet wide? 12. So if this is 19, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 12 is about here. There's this car that's 12 feet wide. Okay, just pretend that that's a car. Okay? And then there's a gap of how much? 18. So there's a gap of 18 feet. And then finally, here's the other car. Okay, there's that car. And this one is 12 feet wide as well. Now look very, very carefully as far as the picture. So here's this car. Here's this car. And we traveled 19.5 feet to the right when it hit the ground. So here's 12. How much more do I have to go after 12 to reach that? 7.5. So 7.5 is going to get me here. You with me how I did this? So that will tell me it'll be between the cars. Okay? How many feet, you tell me, would this value right here be if I were to hit this car right here? What would you approximate it to? A little bit over 30. Because if you said exactly 30, 30 is 12 and 18, it would hit right there. You see what I'm saying? So it's like maybe 32 would give me up here, 33 would get me up here, so on and so forth. You see what I'm saying? As far as how far you throw it. Okay, 29.5 would actually be a little bit short. Okay, because it didn't cross that threshold of 30. Now, let me show you the shortcuts. If I wanted to do it with the menu solve feature, here we go. I do menu 3.1, and I do 12 times the sine of 25 degrees, please correct me if I'm wrong, times t minus 16t squared plus 42, and I want to see when does this equal 0. So equals 0, comma t. Notice the answer that it gives me. It gave me a 1.786, which is a lot more accurate. So let me highlight what it gave me. It gave me this, which is a lot more accurate than the other one that was down here at 1.79. There's those 3 decimal places that I'm looking for, okay? Now, if you're lazy like me, you don't want to type all this in again. And you don't have to. Check this out. On the graph, you already have these stored. Look at how bold these things are. They're already stored. So if you want to see when is y1 of t equal to 0 on the other screen, you can. Just do this. Menu 3.1, when y1 of t, notice that it's bolded, is equal to 0. This is how we use it in calc. Done. You don't have to retype all of that. Can someone tell me why we have 2 answers? Nice. T squared because it's a quadratic parabola. So if I looked at the graph that I had from before, escape to get rid of that, this is what the graph is doing. It's falling, 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 but it also does this because of this negative 16t squared. This negative says that it's actually going to go backwards as well. But why do we not count this answer over here? Why do we not count it? Because it's negative what? Time. And we're not going to look at negative time. We're only looking at positive time. Last but not least, why is it that these numbers that I found, why are they different and not the same? If I created a parabola, why aren't these exactly the same? Shouldn't it be like in the middle of that? The reason of that is this. Here's that building, and when you launched it a little bit up, and then it fell. It still had this to come left, and this is that negative 1.4, and this is that 1.78. You with me? The middle actually occurs here. Can someone tell me why? It went up and it reached its apex. What would I have to have done to the original equation so that the apex was in fact right here? Wait, say again. Drop it, yes, or kick it at a
nudge it off.
at a what? 0 degree angle. So if you kicked it at a 0, it's just going to go horizontal and it drops per se. But if you did it at a 25, you launch it up before it comes back down. You with me? Alright, so check this out. If I wanted you to tell me how long was that in the air, we already know the answer. What was the answer that we got? 1.78-ish, right? So we got this answer right here. You'll say 1.786, it was in the air. Okay, let me show you a shortcut. I'm going to show you exposure to this problem right here. I'm going to need it to show what I'm talking about right now. So, what I want you to do is with the calculator, follow me. We're going to solve the most important piece of these 3 right here. The most important piece is how long was that thing in the air? What was the flight time of that thing in the air? Here we go. If I want to know how long, time-wise, this was in the air, what am I going to do? Y equals what? 0. You with me? So we're going to set this equal to 0. This is what I hope most of you do for the quiz. So 80, 20, 16. Here we go. So this is very important what I'm about to show you. We have certain things already stored, right? We have things stored on that other function. So control right, I can press delete 3 times, and then yes, to get rid of everything on that graph. Then I can come back here and I want to say, I want to clear everything in storage because I got some things stored. I want to clear it. Menu 1.4, pressing OK, and then menu 1.5, get a nice clean page. And again, you can watch the video later if you need to. Okay. Here we go. Menu 3.1, we want to set 0 equal to that y function that we were looking at, which is 80 sine 20 and then minus 16. So here we go. 80 times the sine of 20 degrees times t minus 16t squared. Is there a plus h value? No, because you're kicking it, or you're launching it from what? From the ground. So comma t, how long was that in the air? 1.710. Okay? So 1.710, what is it? Seconds. Now this is very important what I'm about to show you. The horizontal range is when you launched it, this right here will tell you the horizontal range. You with me? So if it took 1.710 seconds to go from here to here, then what could I do with 1.7? I could plug it in here so that I could see x-wise how far did it travel. You with me? So I'm going to go to my calculator and I'm going to put 80 cosine 20 times what I got for that x. So 80 times the cosine of 20 times 1.710. And you get 128.55. Okay? So 128.55 is the feet that it traveled horizontally to get there. All this, that's 128.55 feet long. Okay, last thing and then we'll take the quiz. Okay? The maximum height. The maximum height I will highlight in black right here. This is the maximum height. It happens at the apex of that parabola, the vertex. Okay? What could I do with this number to find this y value? Divide by 2. Cut it in half. Here we go. So go into my calculator. We're going to cut this 1.710 divided by 2, which gives me half the time. And now that I have half the time, what am I going to do with that 0.855? Plug it into which one? Actually, we're going to plug it in to here so that we can solve. So I'll put it in green. We're going to solve it right here. We're going to put 0.855 at that time so we can know how high it is. Y is the height. X is the horizontal travel. You with me? Or again, X is the position x-wise and Y is the position y-wise. You with me? So let's put 0.855 in this equation right here. Okay? Here we go. So we have 80 times the sine of 20, times 0.855 minus 16 times 0.855 squared. Did y'all get the same? Yes. This is my max height that it will be. 11.698 feet high. That's this right there. Are we good? The last shortcut that I'll show you to get these points really fast revolve around something that you learned in Algebra 2. First of all, what is this? Quadratic standard form, right? Quadratic standard form. Looking at this, I want you to look at these x's like we've been looking at those t's on that y function. Can someone tell me what the a value of this equation would be? Negative 16. It's the coefficient in front of the quote-unquote x squared term. What's the b value? 80 times the sine of 20. What's the c value in this equation? 0. There's not one. And if you remember this, it's been a while. When you have a vertex that you're trying to find the x value to, the way you do that is you can use this and say negative b over 2a. That will give you the x value. You see what I'm saying? So b over here is 80, so it's a negative b over 2a. And if I put that into my calculator, this will tell me the x value that we got of that when we divided 1.710 by 2. Okay, so let's go ahead and go to the calculator. So 80, 20, 216. So we have, control divide negative 80 times the sine of 20 divided by 2 times parentheses negative 16. Look at that, you get the same thing. So now that you have the x value, you can just plug it into the x, and, the y, to see how high was it there. Or you can multiply it by 2 and plug it into the x to see how far was it launched. Does that make sense? More than enough stuff to do very well on the quiz today. Okay, so what I want you to do is I want you to